Hello, we are Group 3, and we're presenting about the study of current marine trash removal methods, Manta versus manned boats. Manta stands for Multi-Purpose Aquatic Navigator and Trash Annihilator. Group 3 consists of myself, Daniel Diaz del Castillo, and Tessa Spacher. Marine debris is a huge issue around the world. Trash that is floating on top of water is also called floatables, a term coined by the National Oceanic and Atmospheric Administration. We could see this issue in our backyard here in the Schuylkill River. Here's an example of pictures I took when I was walking on the Schuylkill River. There is an overwhelming amount of data showing that trash or debris is really a huge issue in our waters around the world. In the US specifically, there is a huge amount of plastic generated versus what is actually harvested or collected, and that is very alarming. Overall, the current solutions that exist are not enough to bridge this gap. There's the Philadelphia Water Department that is locally working to fix this issue, as well as many other volunteering organizations locally and around the world. However, everybody on Earth is really affected by this issue. There are current solutions that exist, such as policies, floatable tools such as manned vessels, as well as static vessels. There are many concepts that exist, including the Way Shark, which is a partially autonomous system, as well as a static ocean cleanup system. And there's the RE Roy, which is a very commonly used vessel in our river and around the world. Another proposed concept is the Manta. The Manta is a fully autonomous, all-electric vessel which consists of electric motors that are on the back of pontoons, V-wing frames which are designed to have a larger frontal cross-sectional area in order to collect a greater amount of trash, as well as a conveyor belt in order to lift trash from the water. There's a shredder to compact the trash in order to harness more debris on the vessel, and there's a waste bin to collect it. Because this is autonomous, it has many sensors, including cameras. For this sustainability comparison, we will be comparing the Manta versus the current solution of the RE Roy.
We analyzed several aspects of the two systems in order to determine sustainability. We calculated the energy required to pick up 1,000 cubic yards of trash and the carbon dioxide emissions per 1 kilowatt hour. We also compared the initial investment and operating costs. Lastly, we compared the impact as cubic yards of trash collected per year. The image on the right shows a more detailed feature comparison of the two systems. Here are the results. The Manta did significantly better in all categories, so we included a percent improvement column. You can see the Manta is at least 96% better for the environment in terms of energy use and carbon dioxide emissions, while costing roughly 97% less and having 38% more of an impact. The Manta uses two small electric engines, while the RE Roy has a diesel motor. Based on energy use, one RE Roy is equivalent to 189 Manta subsystems. The carbon dioxide comparison is similarly stark. The graph on the left shows the CO2 emissions in kilograms per year for both systems. Currently, the Manta pulls its power from a coal-fired electric plant, but potential future work could switch that to a nuclear power plant or photovoltaic. The graph on the right shows how that future work could further improve emissions for a range of greenhouse gases. Nuclear has one exception, where nuclear plants emit more sulfur dioxide. Solar, of course, is the best in terms of emissions. This data is from life cycle analysis, which explains why solar has some emissions. The Philadelphia Water Department publishes the yearly trash collected by the RE Roy and how many days it was operational. From there, a rate could be determined. The Manta was designed to meet a similar rate of trash collection, but the Manta can run nearly year-long. One work week was subtracted for maintenance activities, so the Manta has a much improved impact. The RE Roy's costs were also published. It's worth noting that the initial investment cost comparison doesn't quite match. The Manta is a senior design project with no overhead costs. That $7,100 is purely for construction costs. The operating cost for the Manta was based on electricity costs and trash disposal costs. The decision matrix became almost superfluous because the sustainability analysis was so obvious, but here is the decision matrix. The Manta scored better in every category, which makes sense. The Manta was designed to better meet the Philadelphia Water Department's needs. It was designed to be cheap, energy efficient, and impactful. With regards to the 4 Ps, the Manta is also a clear winner. The Manta emits less, so it's better for the planet. The Manta costs less, so it's better for prosperity. It performs better than the RE Roy. With regard to people, the Manta could potentially cause job loss, as less laborers would be needed to clean the rivers. However, the Manta could create more skilled jobs and prevent employee risk. To conclude, Our waterways are becoming increasingly polluted at a rate we cannot sustain. The Manta is a viable and sustainable option to address this issue and protect our waterways. Thank you. Here are our references, and here is the senior design patent that is pending.